All right, in this video, we're rationalizing denominators again. So in example A, we have a cubed root of 3. So remember that if we're doing something like 1 over the square root of 3 and we wanted to rationalize that denominator, we would multiply top and bottom by the square root of 3. The reason why we were doing that is we were trying to get underneath the radical here 2 3's. Why? Because the index here is 2, right? Because the square root has an index of 2. And if we have 3 squared, then what happens is that index and the exponent match up. And that means we can basically cancel out the radical and just leave what's in the denominator there. Just the radicand comes out and the symbol for the radical disappears. And of course, in this particular example, the numerator would be the square root of 3. All right, so that's how we handle the square roots. But to handle a cube root, we have to do the same thing, but this time we're not trying to get 2 of the radicand under the symbol. We're trying to get 3 of it because we want the cube root to basically disappear from the denominator. When I look at example A, I'm going to ask myself, what would I have to multiply that cube root by so that I would end up having 3 3's under the radicand? Well, I'll multiply it by the cube root of 3 times 3, or in other words, the cube root of 3 squared, or in other words, 9, right? Because then what will happen here in the denominator, when I multiply these together, I'll end up having the cube root of 3 to the third power, right? Because 3 times 3 times 3 is 3 to the third. Then the index and the exponent will match up and we'll be able to drop the radical sign. Now in the numerator, we have to multiply by the same thing, the cube root of 3 times 3, or the cube root of 9. So we'll end up having negative 4 times the cube root of 9. And then because these two match up here, the index and the exponent, we can leave the denominator as just 3, and we'll have negative 4 times the cube root of 9. And that's the answer for part A. Now for part B, in the denominator, we have 2 terms, right, that both have radicals. And to handle a binomial in the denominator, when you want to rationalize the denominator, you have to multiply by the conjugate, right? So what I'm going to do here is to say I need to multiply the denominator by exactly the same as what's there, but we change the sign in the middle, right? Change it to the opposite of what it is. It's negative now, so we're going to multiply by the same thing with a positive sign in between. You have to do that to both the top and the bottom. So from there, we're going to remember that this is the difference of 2 squares product, so we can just square the first term, giving you just x plus h, because remember when you square that radical, the radical disappears. And then for the second product, we'll have negative x only, right? Because the square root again will disappear when you square it. Now, minus x and x will cancel out nicely for us later, so that's really helpful. And in the top, we're basically going to have to do the foiling here. So we're going to have to expand that out the long way. So the square root of x plus h times the square root of x plus h is going to end up giving you x plus h. Then we'll have the square root of x plus h times the square root of x. That's going to give you positive the square root of, it's going to be basically x underneath times x plus h, right? So remember, what's inside gets multiplied by what's inside. So we multiply the 2 radicands. So we're basically going to have that for the middle piece. Then we'll have a positive square root of x times a positive square root of x plus h. So we'll have another one of these x times x plus h terms. And then lastly, we're going to have the square root of x times the square root of x, which of course will give us just x. Okay, so it's quite long, but when we clean this up, we're going to see that the final answer will be what? The x's will cancel out here, so our denominator is very simply x. Then we'll have an x here and an x here, so that will end up giving us 2x, and then we have plus h. And then finally we have underneath the radicand, if you want to distribute there, you can distribute and say that you'll end up having x squared plus x times h. And because we have 2 of these, we can just write them as 2 of them, so we don't have to go ahead and do the second one. We'll just combine it with the other. So we'll have 2 times the square root of x squared plus x plus h. Okay, and that's it. For the final example, example C, what we're going to do is do the same thing we did just a minute ago. We're going to multiply top and bottom of that rational expression by the conjugate. So I'm rewriting it now just to give us some room. We're going to multiply the top and bottom of the fraction by a times the square root of x plus 3. So a times the square root of x plus 3. Okay, so when multiplying these out, we're going to get a times the square root of x times a times the square root of x, which is going to give you a squared times just x, because the square root of x times the square root of x is going to allow us to drop the radical sign, then a times the square root of x times 3, which is going to give you positive 3a square roots of x. And then we'll have positive 3 times a square roots of x, which is going to give you positive 3a square roots of x again. And then finally, positive 3 times positive 3, which is going to give you a 9. All right, draw your fraction bar, and then let's go ahead and multiply out the denominator. It's very nice here because we have a difference of two squares product, so we just have to multiply the first two terms and the last two terms. So a times the square root of x times a times the square root of x is just going to be a squared times x. And then we're going to have negative 9 beyond that. All right, from there, let's go ahead and just clean up and simplify the numerator a little bit, right? So we have this positive 3a times the square root of x plus another positive 3a times the square root of x. We're going to get a squared x plus 6a square roots of x plus 9. And then in the denominator, we will have a squared x minus 9. And remember, the whole point of doing this is to get the radical out of the denominator, which we've managed to do.